some 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 awesome stuff, nje. Like when you have the technology and it allows you to do some stuff, use the technology to its
Yes.
full potential. It's also for my own practice because yeah. So let me start off by doing this before we start everything, because there has to be that intro of a lesson. And I hope this intro can come automatically without me having to force it. Right, let me see.
Simplified, or a set of guys who makes it looks easy. Your number one learning channel. Ooh, ooh.
That's dope. I created
Oh, that's actually a
no,
nice intro.
yeah, man. I created I created that through I was trying that. You see this app that they use for making music online, Suno. Put it Suno or something. So I was trying
Okay.
that app. I was trying that app out because I needed something which is gonna, when you play music on media platforms like perhaps you put it on Facebook or YouTube or wherever. Like there's that thing of licensing and stuff. So I needed a song that's gonna be like for about my company, which is Simplified RSA. So I took a guitar and then I just played the bass line like and then I put some words. I'm like and then voila, and then we had a song. So
Oh,
I
that's
just did
nice.
some yeah, I
That's
just
really
put it
nice and
over.
creative.
Yeah, man. Like, we live in a world of AI, so life should be
Yes.
as easy.
True.
But anyway, back to the real stuff now. Hey, you know, I'm not worried about I'm not worried about definitions. I'm not
Mm,
things where there's you must state Newton's laws in words. It doesn't bother me. Reason being,
mm,
I know that if you are under pressure and you know that tomorrow I'm writing a physics exam of some sort, it is your responsibility to study. And students, they make sure they memorize definitions, even though they don't understand what the definition might mean. But for the sake of getting marks, if they say state Newton's first law of motion in words, you're gonna go ahead and say "Kasikuasa how" based on what you know, and say this and this and this and this and this and that. And that would be used defining it based on what you know. And that 2 marks is nothing, man. Every student still get that. The only
yes.
thing that I worry about, or not necessarily me worrying about, but the only thing that I feel you should invest your time in understanding perfectly is your free body diagram. Because if you get a free body diagram wrong, all the calculations that comes after may not make sense, because all the calculations are references that comes from your vector diagram. So
Mm,
remember, I always say Newton's first law and second law, they go together. It's just that with Newton's first law, it's either an object is not moving at all, or even if it moves, it is limited. It can only, even if it moves, it may be moving at a constant velocity without any acceleration happening. So we say it will continue to be like that until a force is acted upon on the board or whatsoever. And then while it is moving, if there could be some acceleration happening, that's when we join in Newton's second law. But for interest's sake, before we do 2.1, let's go through the question that we have. So a crate of mass 25 kg slides down a rough inclined plane at a constant speed of 2 meters per second towards point A. Sharp. Uh, Funny. Like this is an interesting story. I just want us to get the whole concept from the first line. So a crate of 25 kg slides down a rough inclined plane at a constant speed of 2 meters per second. Let me pause there. The part where you had constant speed, what comes to your mind?
Constant speed.
is from our conversation last time. What does constant speed means in terms of other things?
Um, is it something that has to do with velocity?
Well, remember speed itself does relate to velocity. When we talk about speed, it's when we're not mentioning the direction as such. But since we can see the direction of where it is going because it is sliding towards point A, then we can convert the speed and call it velocity because now it has direction, so it is a vector.
Can you please come again on that one?
But I was saying, remember how we differentiate speed and constant? I mean speed and velocity. Previously, when we talk about vectors and scalars, we got to a point where we said speed, it can be considered as a scalar because we don't mention the direction. And then velocity, it is considered as a vector because direction matters. So for this instant, we know that we do know that the constant speed of 2 meters of that block, it is sliding towards point A. So since we can see the direction of where it is going, we can consider it as a vector. I get that. But constant speed or constant velocity must give you some important information. The reason being, remember, the traditional raw way of calculating acceleration would say acceleration is changing velocity over the change in time, right? And since you say velocity is the change in velocity, or it always be final velocity minus initial velocity over whatever change in time it may be. But if if it is constant, it means from point A, it would be 2 meters per second. Point B, it would still be 2 meters per second if we are calculating the change. Meaning that change would be 2 minus 2 over the change in time, which will be 0 over the change in time. So every time a velocity is constant, it means acceleration will always be 0 because the final velocity and the initial velocity will always be the same. Do you see that?
Yes.
Dude, another interesting thing that you don't see from these equations is that the very same traditional way of calculating acceleration like this, when you say change in velocity over change in time, if you play around with that equation, suppose I choose to play around with that equation such that I will end up, say a cross multiply I want to make VF subject of the formula. I want to calculate the final velocity, meaning I'll multiply this by this if I cross multiply, and then I'll multiply this by that if I cross multiply, meaning my new formula would be A change in T is equals to VF minus VI. And if I put this in order, I'll put VI to the other side of the equation because I want to calculate VF, and then the sign would change and make it a positive. Therefore, VF would be VI plus a change in T. Now, I want to ask you, is this formula familiar for you?
It is familiar.
And it is that equations of motions you used, right?
Yes.
But you see where we just converted it to how we calculate acceleration normally. So it like literally it is the same formula as this one. I'm just doing this to boost your confidence as to everything we do connects from something we've done in the past. So all this story, I ended up, look, now I'm deviating from our topic because I was just explaining what happens when velocity is constant, so or speed is constant. So with constant speed or constant velocity, since acceleration is changing velocity over the change in time, if there is no change, the initial is the same as the final, then it's going to be 0. And that would be the case all the damn time. Hence, we say, the moment you hear velocity is constant, your mind must click and say, oh yeah, acceleration is 0 in this instant. But this question is a bit interestingly complicated, not in a bad way though. but in an interesting way. Why do I say that? Because while the object is moving down at a constant value, at a constant speed of 2 meters per second towards point A, something is happening. While it's moving towards point A, it's moving there while force F acts on it. And force F acts on it they've shown us the direction of where force F is acting. So imagine that object is laying down at constant velocity, but here goes another force that is pulling it up. Can you paint the scenario? Can you paint the situation of
Yes.
what's going on there?
Yes.
Right. Just keep that thought. Um, yes, so that force that is acting on it, it is parallel to the incline as shown below. Then a constant kinetic frictional force of 40 newtons acts on the crate when the plane is inclined at an angle of 30 degrees with the horizontal. So everything is given to, like, I always say before you answer any question, try to own the diagram. By owning the diagram, I'm saying look at the diagram and see if there's anything that you see yourself before you even approach any question that is given. In this instant, the only thing we need to look at is, oh, okay, I have an angle there. Meaning it's happening in an incline. And I have point E and point B there. Somehow they gave me the distance from there to there. I don't know how that is gonna help how that is gonna help me. I have the mass of the crate and I have the velocity of the crate, which is constant, going to that direction while there's a force putting the crate up. So I don't know, this force probably is smaller than the motion of the crate when it's going to the thingy. But the crate, what I know is I have the mass of the crate, which is 25 kg. Yeah, with that information, I don't know how it's going to help me with. If you are in a hotspot right now and they say define Newton's first law, what do you see?
Newton's first.
Newton's
I'd
first law.
say, I'd say, a body will remain in. Is it a body or a force? Okay, a body will remain in its state of rest at constant velocity unless a force acts on it.
Very good. Very good. But you, Mami, what if now I said to you, forget about the definition. Tell me, think of me as, do you have younger sisters or younger brothers who are like way younger?
Yes,
Like
I
in primary?
yes, in primary school they're all younger. Yeah, I have two and one brother, two sisters and one brother younger than me.
Now here you are as a sister who's in Matric, killing it, mathematics, physics, and they're like, oh man. And then maybe one of them is like interested in what you are doing, and then they see there's Newton's first law, somehow they could read. And they're like, explain to me, what does this law mean? Without having to state a definition in your own understanding. And what are you gonna tell? Like you have the rights to use any words you want, any language you want, to the comfortability of me as your primary school sister or brother. You are telling me now what is Newton's first law? How to say it now?
Okay.
Given that you are allowed to be wrong, they will never know anyway, even if you are wrong or right, because they're not there yet.
Okay, I would tell
Okay.
them that I'm not sure if my definition is gonna be right, but I would explain it in an example way. Like I'll tell them, let's say right now I put a box here on the floor, right? This box will not move. It will stay like this until I I want to say, okay, until I push the box and then the box will move. That's what I'll say.
Mm.
Yeah.
Okay. There's another extension for it.
Another extension.
It's either it is at rest or it is moving at a constant velocity. because
Uh,
there is a case. Like there was a point where people thought every object that is moving is accelerating until some guy called Galileo. He's the one who started the whole theory of what Newton. The like I'm fascinated by the history of science. I always say we have history of Jan van Riebeeck, how he colonized us in South Africa. We have history of the best pop star who was Michael Jackson. We have history of whatever. But then also Newton was alive at some point. There was a time where Newton's first law and second law didn't exist until he had to do the theories. So remember, we have people who go around to go through the academic researches and discover stuff and be innovative about it, be innovative about it for us to get to where we are. So for me and you to have this conversation right now through our screens while you are at the comfort of your home and I'm here, someone played the biggest role in science to end up creating these computers where we press buttons and stuff. Dude, I sometimes think like we humans, we don't appreciate some of the innovation enough to a point like fact that I'm able to go through my phone right now wherever you are in your kitchen and I can see you and we talk and we have a normal and you are the way you are, same movement, and it's all happening in real time. Dude, that is witchcraft. Like, if we think about it proper, like that's witchcraft, dog. Like, remember, uh, for someone my age, uh, uh, I'm from the age of your parents and your mom. Like we are from the same background where we've seen the world without the technologies, without everything. Like we've seen the development of when we used to use phones, which would you wouldn't move around with the phone. It was gonna stay at your house, and then you dial from there. But still, I would be curious as to how does the message go out so fast? Because those phones, they used to have like a cable connecting to their house, and then they would connect like other cables like electricity, and then they would go around the area. Like it was a fascinating thing. But you know the story of how someone took a can, took two cans, and they made holes, and then they tied a rope, and then someone would stay that side, and then and then they would communicate through those cans. I think that theory kind of makes sense because you are talking and it's traveling through a line. So for me, it ended up making sense that, well, at least we have cell phones. Clearly the message travels to wherever the person is. It's just that it's traveling so fast through the cord, because I could see the cord coming from the phone, connecting to the house going to the pool going to wherever. I don't know where it was going. But now, dog, this thing has nothing connected. And I can take this thing, open a green app, go video call. My mom is in Bushback Ridge right now. I'm in Gauteng. I opened video call and I talk like mama, and she would be in bed and she would be like, "Hey, how are you doing?" And I would feel like the presence is there. For the sake of innovation, that is so. I don't know how to say it, but for me, I'm very much fascinated by the whole thing. Maybe I'm fascinated because you guys are just born and these things are there. They don't. They're probably for you.
yes.
Like, not a like So for someone who went, I remember the first time we saw a cell phone where you can take videos and take pictures, because we used to have, even before cell phones, after the development of that, the first cell phone, it was like a calculator. You see how your sharp calculator look with the
Yes.
ink and the yes, the first cell phones, they were like that. They were also fascinating in fact that now you can take a phone and move around with it without anything connected to it. But now we got into a point where everything is just totally witchcraft. And it's because of those scientists who played a biggest role in history for innovations that ends up getting us being here. My biggest worry is, are we gonna be like our generation now? Are we gonna be innovative enough for our future generation to can look back and be like, I can't believe I used to do things like this. Now things are like that. Or I don't know. It's it's one of the things which we're gonna worry about them when we get there. But through the background of the Newton's laws, the reason why I want you to state Newton's laws like you are telling it to your younger sister, the definition doesn't really matter as such. Like you saying a body will remain at rest, da, 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 and then is it a body? Is it a force? No, it's a body, yeah, a body remain at rest. And then if it remains at rest, we are reading this thing from our memory of like you are reading that definition from that line of a textbook the way you saw it. But in reality, Newton's first law, we call it the law of inertia. Newton's first law is that one when you are in a car and your mom is driving and you're sitting at the back and something happens towards the traffic such that she has to stop so fast, and then when she hits the brake and then you hit your face on the back of the, you see that seat from the back, because maybe you're not into, you never had a proper timing, and then when she hits the brake and then you hit yourself, your forehead on that back seat, and they're like, oh, sorry, because they know they didn't drive so well because they stop so fast. That's the rule. So the rule says you will remain, like a body will remain at rest, or it will continue to move at a constant speed or whatever speed it is moving at until another force act on it. So the moment you brake so fast, braking means you stopping from the movement while your body was already still on that movement, and then it is still continuing with that movement. The only way you stop is because now you hit yourself with the seat, so forces you to, because it applied a force on you. The first
Yes.
practical, I don't know if the teacher has done this practical where they put a glass and they put a playing card. You see those playing cards, the ones that we play, ace, joker, the playing cards. So they put it last, they put a playing cards, and then they put a coin on top. Let me see if I can get that practical, that initial practical, just to see how they do it. I'm gonna. Okay, so we can both share the sound.
This is part one of me moving the index card very slowly. Now I'm gonna get the index card out of the way very quickly. Now let's see what happens to the coin. This is part one of me moving the index card very slowly. Now I'm gonna get the index card out of the way very quickly. Now let's see what happens to the coin.
Now, what stood out for you there?
This is
But I'm
part
trying
one of
to,
very
I'm
slowly.
trying to see what was the difference between the first one and the second one. Was it the speed or
So the first one he's moving. The first one he's moving. The first one he's moving the. So he puts the coin on the glass. The first one he move it slow, and then it goes with the paper. And then the second one he just move it so fast, like shoop, and then the coin falls inside.
falls inside? Okay.
So I'm like, what do you think? That explanation of me trying to tell my 5-year-old brother what's going on there is, if you move slow, at that point, the coin, it individually, the coin on top of a paper, it has been at rest. But if you move slow, the coin manages to be the same velocity of the paper, the way it is moving. It's like when the car is moving at a slower pace, even if they hit the brake, you're not gonna go at the back of the seat because you are going at a small speed that is proportional to the actual body. So when it's pulling it slow, the coin moves with the paper because they are at the same um they are moving with the, like, it adjusts to move with the same force or whatever velocity you are applying to the paper. But when you pull it fast, because the coin, it's still at rest. It's that thing, it's the same way when they apply the brake fast when you keep on moving. So since it is still at rest, it couldn't keep up with the velocity of the card. So when you move the paper moves so fast such that the coin moving, it remained at rest. The reason why it fall inside is because it still has, I didn't move from where it is. So because it's on top of the paper, after I move it, it fall inside because it's still at rest at that moment. Hence, it happens so fast. So it's just the explanation of inertia, where everything remains at that velocity or at that speed, unless there is a force. Because by pulling the paper so fast, you are applying the biggest force such that it only applies on the paper, yet the thing was still at rest, then it falls inside. So that's what explains Newton's first law in a simpler manner. So it's just you saying,
Oh.
in summary, you just you saying it doesn't even necessarily has to be a box, or it could be any object. It could be you. It could be your own body. It could be the TV at home. It could be your car. It could be anything, but it will never move until someone moves it. Sometimes Newton's second law, Newton, the woke generations these days, the kids are even undermining the laws because they be like, but if you think of Newton's second laws, or never mind what number it is, if you think of Newton's laws, they are so obvious. I
Mm.
put this I put this thing here and I say to you, this thing will never move unless something moves it. I mean, that's what when you look at it academically, you guys are stressing with something that is nothing. Nothing. Dude, we know it is like that. Like most of Newton's laws, they've been like that. But for me to
Mm.
make peace with my mind, I'm like, we are just glad because we are educated and be in a state where we are able to think rationally. Think of it as your parents didn't take you to grade one. They just left you at home to just know what you know. You'd be the most illiterate person today, such that you wouldn't even comprehend such that if you put something here, it will never move unless something moves it. Maybe. That's what
Yeah.
I'm thinking. Yes, because there was a point where we were probably so less informed, and then as we know things, now genetically we improved such that when we look at the discoveries, they look like they are nothing. And I'm gonna show you something. I'm gonna show you something as we go. I want us to compare. I you're not religious, are you?
I am.
You are, ne?
Like how?
Have you ever like just going to church, having a Bible somewhere in the house,
I
knowing a
am. I
couple of
am.
yeah. I mean, look, but by default, somehow we are all religious because we are scared of what happens after life. So we just need to be safe. Or if
Mm.
afterlife, for me not to burn forever, I need to be safe so I can stay in heaven. So due to that safety, I'm fascinated about how the Bible goes and goes and goes. And I'm also fascinated about how the science world goes and goes and goes. But if you look, most of the things are similar. I'll show you as we go with some of the rules and the discoveries of the scientists, or something that Newton said that I can relate to what the Bible could have said. So both people that they are trying to, with the science, it's innovation to improve life. With the Bible, is to control the world. Because I feel like if Christianity didn't exist, there are other people who would be horrible. Like there are other people who are just bad people. Like there's someone who would go around and be violent to people, kill people, shoot people, but because you are scared, you're gonna get arrested. You end up not doing that. But then also you are scared, like, what if when I die, I burn? Let me not do this thing. So that fear of if I die, I might be like, actually, that's why we're all religious, to be honest. That fear of when I die, where do I go? It's the one that keeps us disciplined to, to do the right
Yes.
thing. So, imagine if there was no someone who wrote something to control such type of the world. The problem is when we try to mix the two, of which it is not wrong if you can pick up some. I strongly believe both Isaac Newton and them, they could have been the advanced because let me not go deep into this. I'm gonna go far. Let me stick to the physics. When I get carried away, I'm so fascinated by this conversation, such that it's gonna take me to wherever. But anyway, we are here. Um, one of the things that makes me not to worry again is that we are not in a hurry of anything. We're just practicing for now because we have like a full week of everyone will be the school is closed, so we are like free to can cover as much content as we can. We have to draw
Yes.
and label a free body diagram showing all the forces acting on crate A. No. Showing all the forces acting on the crate as it moves towards point A. You know, this one, before we do it together, I would like you to attempt the free body diagram yourself. But you see, it is 4 marks, right?
Mm-hmm.
Meaning you have to show all the forces, and you must be able to name them. I'm more interested in also you must consider the angle somehow. But for now, if you are to show all the forces, given that you are allowed to be wrong, if you are to show all the forces acting on the object, given that you are allowed to be wrong, please attempt, and then you send me the picture on WhatsApp, and then we're gonna do it together.
Okay. Including the angle.
In, including the angle, yes.
Okay.
Sure. Let me give you 3-4 minutes.
Yeah.
Sure. I'm just gonna get myself something to drink while you do it.
Okay.
Right.
Almost done.
No, no pressure.
Okay, I'm done. But ish. Wait, let me just read the question one more time.
It's just a free body diagram, a labeled free body diagram.
Yeah, it's just the angle. I don't know it. I got the
The
other ones.
problem
It's
is
just the
the
angle.
angle.
Yes.
And the reason why I want you to consider the angle is because on the image of the body diagram itself, there's no mark for considering the angle. The angle is only applicable for you when you are actually doing the calculations.
Let me just read the
Because
question one more time so I can make sure like where to put the angle. Okay, actually, can you like find the angle together? Like, ish, I don't know. Let me just send
yeah,
the one I.
we need to build that confidence eventually. Being wrong is not a problem.
Okay, let me just take a picture of what I have now.
Okay.
That's what I have for now.
Okay. That's what I was thinking. Okay. Okay. So you didn't consider the angle on this one, the one that you sent.
Yeah.
Okay. If you were to manipulate it to include the angle, how do you do it?
Meaning?
If you were from the one that you said, so let's talk about the forces that you have. If I was to give you a mark for each force, I would give you 2 marks.
Mm-hmm.
The normal force that is acting perpendicular to the object, and also the kinetic friction. Now, as much as the object is moving towards point A, when you look at the object itself, to which direction is the force F acting towards?
Downwards?
Downwards. But the arrow of the force F is pointing
Oh,
there.
upwards.
Yes. So why is yours now changing direction and move like that? Isn't that concerning?
Yo, it's wait, actually, let me do it one more minute. Let me read. Maybe I didn't read something properly.
I do have time. Before we do it together, I want you to attempt it until you feel like you can't, and then we do it together. Look, let me give you an advice. Don't overthink the question. Just label the forces the way you know them yourself. Like, for instance, gravitational force acts downwards. By downwards, I mean exactly south. So if you have up, down, left, right, FG always acts downwards, always down to the center of the N. That's FG. If you can know that FG always acts downward, it will help you to consider the angle. Let's go another attempt. If this one doesn't work out, then we're gonna draw it together.
Okay.
Okay. like we are canceling the spirit of memorizing. We're trying to find a way. How can these things make sense to us without having to overthink?
Mm. Okay. Um, Wait, did you say my FG was right or it wasn't right?
Okay, regardless of whether I think it's right or not, I'm saying FG acts downwards. Even if something
Oh
is at
yes. Why did I
yes,
do it like that? Oh
I don't know. Maybe because it was on an angle like that. Hence, you know,
no, but normally I actually make it face downwards. I wonder why.
yes, it's always down. So when it's down, the only way you can fix other things is to consider the angle to take it to where it is, type of a thing. You see?
Yes. Yeah. Now I have another one. Let me send it.
Hey, let's see.
Oh, you know what confused me? Why I made it? Why I made my FG like that?
Hmm?
It's because I thought I was going to do FG like perpendicular, FG parallel. Now I see where I went wrong.
Yes. And by you considering the angle,
I
that's when
didn't write
you
FG and FG.
FG perpendicular. Yeah,
Okay, I send
yes,
another one now.
yeah, yes. With this one, you get all the full marks. But just by drawing that thing only, you're not gonna get all the full marks. You have to then name the forces on the side. So you're gonna say Fn means this, Fk means this, F means this, Fg means this to get the full 4 marks, right?
Really?
Yeah, unless you name them from where they are directly. Look, we are trying to be as neat as we can with our work, such that the person who's marking the script, they have no right to can say, but here you were wrong. So look, I use a point. Before we even proceed, what do you think is the difference between a vector diagram and a free body diagram?
The other one is a dot. The other one is like a square. Oh no, vector, not force diagram. Sorry. Um, which one is a vector diagram again?
I'm not laughing because you are wrong. I'm just laughing at the. So, which one is a dot?
No, I made a mistake. The one I was speaking about, the box one, is the force diagram, not um vector diagram.
A diagram. So, what do you think is the difference between vector diagram and free body diagram?
I'm just trying to remember a vector diagram.
Okay.
Um, which one is a vector diagram again?
And that's
I,
that's
I,
that's why I was asking the differences. I never really wanted to define vector diagram for now. I just wanted to see to pick up if you get the difference. We'll talk about it though. It's fine.
okay.
So
But
those
I'm trying to remember the vector diagram.
don't worry. So you
Okay.
have FG, you have FN. But this is where the angle comes in. As much as our FN is perpendicular to the crate, FG was supposed to act exactly opposite to it, downwards like that. That's when you have your F perpendicular to the block. FG perpendicular. Because as much as it is acting downwards, it was supposed to be acting opposite the normal force. That's when your angle comes in. So that angle that is formed there, it is the same as that 30. That 30 degrees will now be implemented here. So you would have your 30 degrees here. That's how the angle comes in, you see.
So we
Automatically,
just
yes,
so we just add FG perpendicular. We don't add FG parallel to the diagram.
we do, because to complete a triangle, because remember we have to find those sides. So to complete a triangle, we're gonna have another one there acting to that direction, which is our F parallel. So F parallel is the one that is acting to this direction. But for now, we are not there yet. I'm just saying, this is FG parallel. So they are formed FG parallel and FG perpendicular. They have to both coexist because they support your FG, which is not acting opposite to FN. So that's just by considering the angle, it's just to know that between FG perpendicular, FG, which is now the hypotenuse, that angle that is formed there is the same as the angle that is found there all the time. Just know that if you have something here, and then you have theta, and then you have a crate, never mind the other forces. For that crate, you will have a normal force. After having a normal force, you would have a gravitational force acting exactly downwards, Fg. Now, because of that Fg acting downwards, it's going to form an angle, which is going to show Fg perpendicular, which has to be opposite the normal force, and also Fg parallel, which is acting to the direction of it's mostly the, I would say to the direction of the, I don't want to say friction, but I just want to say this angle will then come and be here all the time. That's how you relate your angle to your object, because you need that part.
Oh.
So that angle is always going to play a role like that. That's how it's going to work out. We are not memorizing. We are just knowing whenever the object is acting. The reason why I don't want us to memorize, as we go, we're going to get a different scenario. A different scenario would be an object would be on a horizontal plane, but someone decides to pull that object with an angle of a force that goes to that direction, you see, such that it ends up forming a certain force, a certain angle again. Those, like, we have different scenarios, hence I don't want us to memorize. I want us to be confident as to what we are doing, because once you have that triangle, you know how to play around your trigonometric identities from the things we learn in mathematics, right?
Yes.
Awesome. But the most important part of the free body diagram for 2.2 is the purple forces, the 4 purple forces.
That's where you get your marks.
That's where you get your marks. The FG parallel and the FG perpendicular is just to help you calculate everything with confidence. You will see when we're calculating how important it is. Because now, for instance, we need to calculate the magnitude of F. Do you want to try it first?
Yes.
Okay. Let's see.
Okay. Where's my pen? Okay.
It's under the... I think the next improvement we're going to have in terms of innovation maybe in 10 years time from now, when we have Zoom meetings, it won't be about screens or anything. You would be able to see the entire room in 3D. Worry, okay, like now. So you can tell where is your pen in 10 years time from now. I'll be able to tell where is your pen from this side, because I'll have probably the view of the table and
Yes. Technology keeps improving.
you see. So we need you guys to get the physics right so you can create those things, because it's your turn now. You see. So
Yes.
you must know what I when I get to be what in the what field. At the moment you don't have the pressure of what you're gonna do when you get to university. It's not that much. Do you feel like the pressure is there, or you just like, ah, I'll see there?
Um, I don't think I feel the pressure yet.
Yeah.
Yeah.
And do not pressurize yourself. I always tell everyone that there's no need for like pressurizing yourself so hard, whether you want to become a doctor or a nurse or a soldier. Just relax. It will come to you. As long as when you focus on a day to get the good marks that you need, then they will allow you to can choose whatever you want to choose. Or they will allow
Mm,
you to choose then, but whatever that has to choose you.
true, true. Uh, I'm almost done. I'm almost done.
Okay.
I'm almost done now. Now, almost done.
Take your time. We are not on that thing of the meeting is gonna expire in 40 minutes, remember?
Yeah, true, true. Oh, really? It's different now.
Yeah. Now we just have lessons. When we're done, we're done. When we continue, we continue. When we take a break, it would be our choice to take a break. So I've unlocked the
Oh.
premium Zoom. It's no longer that 40-minute schedules. I was like, let me be serious. So these kids must pass. There's no excuse, Yahori. But it's because the periods are 40 minutes. I'm like, let's stop that and like just we are canceling those excuses.
Yes. Um, G is 25 times 9. I'm on the last step now, and
Okay?
I'm almost done. I'm on the last step now.
Nah, relax. Just enjoy it while you are doing it. Don't we are not it's not some war. We are just solving physics.
I think I did a mistake here. How did I get a negative number?
If you got a negative number, remember negative number in physics, it depends on which side did you choose as positive and which
As
side you didn't.
positive. Okay.
Yeah. So in physics, negative means direction. Also positive means direction. And in physics, you are free to determine the direction the way you want, as long as you know when you find your answer, what does it represent based on the choices that you made of the directions.
So if I got a negative number, it means I should just write it as the answer and then the direction.
Yes, I think.
Okay, I got an answer. Should I say the answer or should I send a picture?
Uh, what's your answer? I can write it down first before I worry about the picture.
Okay, my answer was my final answer was 82.5 newtons upwards.
Upwards.
Yes.
Upwards how?
Oh no, not upwards. No, because I get these two that well. Okay, I don't know if that's upwards or like it's to the left, but I chose the other side as positive, so it gave me a negative number.
This was a positive, and then this was your negative direction.
Well, I chose the one with that one is positive.
This one is positive,
Yes.
and then the opposite is negative.
Mm.
Right. Now give me your steps. I'll write them down. What is your first step?
Okay, my first step, I used that F net equals to MA formula.
Very good. That's the only first step you have at the moment. F net is equals to MA. Very good.
And then the next step was I said F perpendicular minus FK plus F equals to MA.
You see, I'm clapping hands for you. Clapping hands for you because I was just a bit worried about that part, Mara. So since the object is moving to the left with 2 meters per second, from your vector diagram, the only force that is moving to that direction is F parallel, FG parallel.
Mm.
And then it's gonna be FG parallel minus F plus FK is equals to MA. That's what you did, right?
Yes.
Ah, very good. Very good. So FG perpendicular minus F minus FK is equals to MA. Now let's substitute our substitutions.
Yes. Substitution. For the FJ not perpendicular parallel, I said MG sine theta, right?
Ah,
And then I subbed it, which was 25 times 9.8 sine 30.
uh-huh. So
Yes.
minus
And
F minus the kinetic friction we
40,
had, foot, is equals to M, which is
which is
25
25 times 0 because it's constant speed.
because it's constant speed. Now, since we are calculating F, I can quickly make F subject of the formula. So we have
Okay.
minus is equals to minus mg sine 30 plus foot if I take them to the other side. And then if I divide by a negative, I would have that F is equals to mg sine 30 plus foot. That's where your value is. Therefore, there's going to be mg 25 times 9.8 times sine 30, which is 0.5 plus foot. And then it gives you 82.5.
Mm.
There is no other better way of doing this than that. So
Yeah.
since we've done 2.1, 2.2, and 2.3, I'm fine now. I want you to attempt 2.4 and the rest. No pressure. No pressure.
Okay.
You can do them in your own time, and then when you are done, we can take it from here.
Okay.
Just when you are just do them, Jay. When you are done, you're gonna send me the pictures. No, you can do them anytime. I will be available, Jay. I'm not even under pressure with other students as well, because most of them they just went for school holidays yesterday. So most of them they want to rest for the weekend, such that we're gonna resume Monday. So I know for the next week, every one of us, next week, guys, we're gonna work. Next week we're gonna work, because also for you, it means I'm gonna ask you to create time. Even when I'm teaching them something, I don't mind for you to be part of all the works that I'm gonna put in them through, because it's gonna help you a lot. Like
Mm.
if we can if we can consistently push with them for the whole week, you might feel like when they are on school holidays, when are you gonna feel like you are at a school for a week? It's gonna be the other way around, because now we're gonna be working. So, Mara, still, I'm not gonna put pressure. I'm not gonna put pressure. It's just that for your sake, it's the consistency of knowing that you are writing in 2 months' time.
Yes.
Not even two, in a month.
It's like a month. Yes.
Yes, yes, in a month, because we are starting April next week, and if we're starting April next week, it means roughly
Yes.
a month and a half I would be doing the things. So please, just avail yourself. Like prepare your schedule for next week, Nyana, just to make it. So by the time school reopens, me and you could have covered all the stuff that we needed to worry about, which could be grade 11 work, grade 10 work. And then we stick to
Yes.
our formula. But I don't know how your day is gonna go about today. If you can try to finish that question today, it would be nice. But if you fail to finish it today, then we're gonna have to do it tomorrow. So we're gonna finish 2.2 first. We're gonna finish 2.4 and the other questions before we start the next one.
Okay, I'll try and finish it today because I don't have to do today.
Yeah, if we have time and time allows, we might as well just do this. I won't
Okay.
have even cook you out of the meeting. You can leave the meeting yourself, since we are not canceling anything. We are not going to
Ah.
this meeting. The freedom is here. All right.
No, I think you should end the meeting because it feels like now I'm leaving class and class is not even done.
You're not leaving class. I'm gonna just there's an option to say end on the side, or even to just cancel it. Let me just say my goodbyes. Goodbye for now until we talk again soon. Hoping we're gonna talk again soon. Yeah.
Yes.
Sharp.
Bye.
Bye. Great. For those who are watching from YouTube, guys, the free lessons are more important than the live lessons, because the live lessons, I just select a certain topic and I just do that certain topic. Look, we couldn't even finish the whole questions, and clearly, I'm not gonna on the second part of the questions. I'm doing this, guys, to make you aware that we are available for like affordable lessons, bruh. Lessons where you are not limited to 1 hour is 5 rand or 3 hours is 10 rand. We have a fixed amount that we pay in a month. Then we just learn. We learn. We'll see how far the student is struggling. And then as we learn, we make sure all the students, they get to be, how do I put this? Think of us as the doctors of the most struggling students. So if your brain is struggling from something that is blocking you from understanding what mathematics is about, we got you, because we are Simplified RSA, the guys who make it look easy. And by making it look easy, I mean we got you to make it look easy for you all the damn time. Till next time.
Simplified RSA, the guys who makes it looks easy. Your number one learning channel.